This is a NEET 2020 question in electric charges and fields. The question says, the electric field at a point on the equatorial plane at a distance r from the center of a dipole having a momentum p is given by. We assume that the separation between the charges is forming a dipole who is having a distance, and that distance is much smaller than the distance of separation at the point where you are calculating the electric field, right. So, what he is saying is, there is a positive charge, there is a negative charge, these two are separated by a certain distance. Now, he is considering a point P on a line called equatorial line. Equatorial line means line passing perpendicular to axial line, who is joining positive and negative charges. So, this is axial line and this is equatorial line, and he is saying that this distance r is much greater than the separation between the two charges, that is quite far. So, to calculate that, I am not going to make a derivation here, but I am just going to tell you that how do you get that, right. Electric field means on that point you shall imagine a unit positive charge. On that unit positive charge, this positive charge applies a force of repulsion. How much is that? 1 by 4 pi epsilon naught between these two q, and here I have imagined only plus 1 by this distance. This is a and this is r, this becomes root of a square plus r square. So, 1 by 4 pi epsilon naught q by r square na, so it becomes a square plus r square, that is f due to plus q. Similarly, this negative charge on this unit positive charge applies a force of attraction, right, that is this way. This is also having the same magnitude, nothing different, but instead of this positive charge I have to write a negative charge. So, this force due to positive charge in magnitude is force due to negative charge, and these two forces are having certain angular separation. How much is that angular separation is? We can, if this angle is theta, this total angle becomes 2 theta. We can calculate F resultant using the vector laws of addition. I am not doing all that, I am not proving all that, but it can be proved that electric field on equatorial line is 1 by 4 pi epsilon naught p by r cube, whereas on axial line it is double as 1 by 4 pi epsilon naught 2 p by r cube. Being he is asking the equatorial line, option D is the right answer for the problem. You can look into the derivation even in the magnetism also I have made. There in terms of magnetism I will get, instead of electric field, electric dipole moment, I will get a magnetic dipole moment, capital M, but the equations remains the same. That is one question. Let us have a look at the other question given in NEET 2016. It says, an electric dipole is placed at an angle of 30 degree with the electric field, that means theta is given for you 30 degree, with an electric field of intensity E is given as 2 into 10 power 5 Newton per Coulomb. It experiences a torque of 4 Newton meter. When the separation, if the length of the dipole is, that is 2a, like I said, from center to here is called 1a, here there is another a, that is called length of the dipole. That means 2a together given for you as 2 centimeter, that is 2 into 10 power minus 2 meter. Then the charge is how much is the question. We can write a formula for the torque as P bar cross E bar, or magnitude of the torque equal to P sin theta. Magnitude of the torque is given for you in the problem as 4 Newton meter. P can be written like 2A into Q into E sin theta. Let us substitute the data and see what happens. 4 equal to 2A is given for you as 2 centimeter, that is 2 into 10 power minus 2 meter. Q I have to find out into, of course, E, that E value is given for as 2 into 10 power 5 and sin 30. Theta is the angle with the electric field. You know, sin 30 is half, so sin 30 and this 2 will cancel. Here also 1 2 can be cancelled. So what is remaining is 2 equal to Q into 10 power plus 3 minus 2 and plus 5. That implies Q equal to 2 by 10 power 3 or 2 into 10 power minus 3 or 2 millicoulomb. That is the answer for the problem. 2 millicoulomb is the answer for the problem. So, both these problems are just basic formulas. You need to know that basic formulas so that you will be able to answer these problems. That is it, and thank you for watching.